Hey, this is your math tutor Jessica. This video will be all about what you need to know in order to work with and understand absolute values. So get your pencil and paper ready because here we go. Today we're going to talk about absolute values. A number's absolute value is its distance from zero, and it's indicated by two vertical bars with the number in the middle that you want to take the absolute value of. So this reads the absolute value of x. So say we wanted to find the absolute value of 3. The absolute value of 3 is 3 because the distance from 0 is 1, 2, 3. If we want the absolute value of negative 3, it's also 3. 1, 2, 3 units from 0. So, in practice, when trying to find the absolute value, you can take the number and remove the negative sign. So, for example, the absolute value of negative 7 is simply 7. The absolute value of negative 8 is 8. Likewise, the absolute value of positive 7 is 7. And the absolute value of positive 8 is 8. What if we have to solve an equation with an absolute value in it? How do we go about solving something like that? Say we had the absolute value of x equals 6. Well, we know from our definition that x can be negative 6 and x can be positive 6. So this means that the absolute value of negative 6 is 6, and also the absolute value of 6 equals 6. So from this, we can see that whatever's inside can have opposite signs and still yield the same answer. And whatever we have on the inside of the absolute value bars is called an argument. So, our argument can be negative or positive. Let's try solving a more complicated equation. We know that our argument can be negative or positive and yield the same absolute value. So, we'll set up our equations to illustrate that. We know x minus 5 can equal 7, and negative x minus 5. If you take the absolute value, it can be 7 as well. So we're going to solve each of these equations individually to find out what our x can be that will get us an absolute value of 7 in our equation. Here, we'll solve for x by first adding 5 to both sides of our equal sign. Add down and we get x equal to 12. Now we'll solve this equation. First, we'll distribute our negative and get negative x plus 5 equals 7. Now, we'll subtract 5 from both sides of our equal sign. Add down and we get negative x equals 2. We're not done yet. We still have this negative on the outside of the x. So we can divide both sides by -1 and get x equals -2. So our solutions to this equation are x equals 12 and x equals -2. Now we can check to see if our solutions are correct by substituting them in for x in our equation. First, we'll check for 12. When substituting 12 into our x, we get the absolute value of 12 minus 5 equals 7. 12 minus 5 is 7, so we have the absolute value of 7 equals 7, and that's true. Now, we'll check to see if x equals to -2 works in our equation. When we substitute -2 in for x, we get the absolute value of -2 minus 5 equals 7. -2 minus 5 is -7, so we have the absolute value of -7 equals 7. And that's also true. So we know that x equals 12 and x equals -2 are the solutions to our equation. Now let's try a different equation. We have the absolute value of 7 plus p minus 3 equals 4. In order to solve this equation, we must first isolate our absolute value. So what we'll do is add 3 to both sides of our equation to get the absolute value by itself. So when we add down, we have the absolute value of 7 plus p equals 7. Now we have our absolute value by itself on one side of the equation and everything else on the other side of the equation. Now we can proceed to solve our equation just as we did the last one. We know that the argument of our absolute value can be either positive or negative and yield the same result. So we'll set up our equation. 7 plus p equals 7, and -7 plus p equals 7. Now we can solve each of these for p and get the solutions to our equation. Let's solve our first equation. First, we'll isolate p by subtracting 7 from both sides of our equation. 7 minus 7, we add down, p equals 0. Next, we'll solve our second equation. First, we'll distribute our negative and get -7 minus p equals 7. Then we'll isolate p by adding 7 to both sides of the equal sign, since we have a -7. Add down and get -p equals 14. We still have this negative out front, so we can divide by a -1 on both sides of the equation and get p equals -14. So our solutions are p equals 0 and p equals -14. Now we'll check to see that our solutions are correct by substituting our values for p back into our original equation. First, we'll check to see if p equal to 0 is correct. When substituting 0 for p in our equation, we get 7 plus 0, absolute value, minus 3 equals 4. 7 plus 0 is 7, so we have the absolute value of 7 minus 3 equals 4. The absolute value of 7 is 7. So we have 7 minus 3 equals 4. 7 minus 3 is indeed 4. 4 equals 4. So that equation is true. Next, we'll check for p equal to negative 14. When we substitute negative 14 in for p, we get 7 plus negative 14, absolute value, minus 3 equals 4. Seven plus negative 14 is negative 7. The absolute value of negative 7 minus 3 equals 4. The absolute value of negative 7 is 7. So 7 minus 3 equals 4. 7 minus 3 is 4. And 4 indeed equals 4. So this is true. And we see that our solutions p equals 0 and p equals 14 are correct. I really hope this video was helpful to you. If you have further questions or any comments, feel free to contact me or post directly to the video page.